All right, so now we move on to question 5. And we start A. L hours of the battery. So L is normally distributed 18 4 squared. And we want to know the probability that L is greater than 16. Well, of course, that's 1 minus the probability that L is less than 16. You can go straight to your calculator. This is 1 minus 0.3085, and that comes to 0.6915. Okay, just one mark for that. So part B, now this is where we need to read the wording of the question carefully. So she has used her calculator for 16 hours. This is conditional probability. We are told, we are given that the batteries have lasted for 16 hours. We want to know what's the probability that they'll be lasting for at least 20 hours. In other words, we want to know the probability that L is greater than 20, given that L is already greater than 16. And that's the key bit here. And this is, well, we know the conditional probability formula. And so this is the probability that L is greater than 20 divided by the probability that L is greater than 16. And that's 0.3085, that's a 4, 5, divided by 0.6915. And that comes out to be 0.4461. Okay, so conditional probability there. And so for all 4 batteries, so that's condition for 1 battery, for all 4 batteries to survive, thus the calculator works, we're looking at 0.4461 to the power 4, and that's 0.04 roughly, about 4% chance of that happening. Now for part C, she's stuck in a couple of new batteries, and she replaces 2 that show the probability her calculator will not stop working for the remainder of exams is 0.199. So for the 2 new batteries, they only have to last 4 hours. So the probability that they last for 4 hours or more is, again, calculator 1 minus 0.000229, which comes out to be 0.9998. So therefore, the probability that the calculator is still working is this, so it's 0.9998 squared, because we want both of them to be working, multiplied by the previous answer, 0.4461 squared, because you've got 2 batteries of the old type, and that, if you calculate it, comes to 0.199 to 3 significant figures. So part D is a hypothesis test. Our null hypothesis is that mu is 18, but the alternative hypothesis, she believes that the average is greater than 18. Now, the original distribution had L as a normal distribution of 18 4 squared, but this is now a sample, so our mean, the sample mean, has a distribution of 18 and 4 squared over 20, which is our sample size. So we've got a sample distribution of 4 squared over 20, and it's that we use in our calculation. So we want to know the probability that x bar was greater than 19.2. Remember, that's the test statistic, 19.2. That's what we actually found, okay, from the test. Given that x bar comes from the sample distribution, normal 18 4 squared over 20. All right, so we must use the sample distribution now. And that's a calculator job. We just go to our calculator. It turns out to be 0.9109, but we want the other way, so it's 1 minus 0.9101, which is 0.0899, which of course is approximately 9%. So that's of the order of 9%. The significance value is 5%, so therefore we do not reject H0. There is insufficient evidence to suggest that the battery life is greater than 18 hours.